guys, so third time's a charm. I'm making this video for the third time this weekend. So first of all, we're in section 6.2 and we're talking about systems of equations. So let's just remind each other that a set of equations, so a set, so more than one equation, a set of equations that have a common solution is called a system of equations, okay? Now I've asked that question now several times, so you're going to have to be able to identify a system of equations. A solution to a system of two equations is a coordinate point that makes both equations true. So yesterday in class we were solving systems by graphing, and remember we were looking for their point of intersection. That's the coordinate point that you're looking for, the point of intersection. Okay, so we learned to solve the systems by graphing. We graph the lines and we find the point they intersect. Recalling that there were three ways that we could get answers. We could have one solution, which means they had a point of intersection. We could get zero solutions, which meant the lines were parallel. And then we had an infinite number of solutions, which means the graphs were the same line. Okay? Today we're going to be talking about solving it algebraically, without graphing. So we are going to solve a system of equations by using substitution. One of the most important skills that we can use is substitution. All right, so let's look at our first example. X plus y equals 6 and x equals y plus 2. So first I know this is a system of equations because I have two equations and I have two variables going on here. Substitution means you are going to plug one equation into the other. So you're going to plug one equation into the other. Write that down. Now, in order to do that, one of the equations has to have one variable like solved for. What I mean by solved for is x plus y has both variables on one side. It doesn't have x solved for or y solved for, like x solved in terms of y or y solved in terms of x. But this bottom equation, it does. I have x equals y plus 2. So x is solved for is what I'm calling it. Now I'm going to take this y plus 2 that we've also said we can call x, and I'm going to plug it into the other equation wherever there is an x. Now remember, when I plug things in, I always like to put them in parentheses, so just be careful about something like that. So when I take y plus 2 and I plug it into the other equation for x, I'm going to get y plus 2 plus y equals 6. Now what I've done is I've made the equation an equation in one variable. So now I do know how to solve that. I combine the like terms first. So y and y is going to give me 2y. So 2y plus 2 equals 6. Then I'm going to subtract 2 on both sides and I'll get 2y equals 4. Then I divide by 2 and I get y equals 2. Okay, so y equals 2. Now remember, the solution to a system of equations is a coordinate point. Now I only have a y, so I need to get my x. So I take that y plus 2 and I plug it into this equation that I can directly plug it in and get an x value. So I'm going to do x equals 2 plus 2, which is 4. So now I also have my x coordinate, and since Coach Fred likes us to consider that these are coordinate points, we're going to write it as a coordinate point. The answer would be 4, 2, okay, and in parentheses. All right, so we substituted one equation in for another. All right, let's look at another example. X plus y equals 5, and x equals y plus 1. So again, we have this equation that has got x solved for in terms of y. So we're going to take this y plus 1. I kind of like to think of it as a new name for x. Instead of calling something x now, we're going to call it y plus 1. So we're going to take that y plus 1 and we're going to plug it in to the x in the other equation. Okay, so our new equation here will become y plus 1 plus y equals 5. Let me do that so we keep our y's same. Then we combine our like terms, so we get 2y plus 1 equals 5. We are going to subtract 1 from both sides. We get 2y equals 4. Oh, and once again, when we divide by 2, we get y equals 2. Not finished, because the solution to a system of equations is a coordinate point where these two lines intersect. Now we're going to get the x, so we're going to plug it back into this easier equation. X equals 2 plus 1, which gives me 3. So then my answer would be 3, 2. I box my answer. So these two lines intersect at the point 3, 2. It means that solution makes both, those coordinate points, if I plug them in, are going to make both equations true. Back to what I said at the beginning. Okay, so that's substitution. However, let's make it a little bit harder. What about when an equation or a variable isn't solved for? So let's look at this example. 3x plus 4y equals 2, and 2x minus y equals 5. So when looking at it, before I decide what I'm going to do, I want you to decide what variable would be the best to solve for. The best one to solve for. So every time you look at a system, if you're going to use substitution, because there are other ways, I want to look at it and say, okay, what would be the best variable here to solve for? Well, how do you determine that? I want you to always look for the variable, that has a coefficient of 1. Okay, and I'm going to explain why tomorrow, but for now I want you to look for the one that has a coefficient of 1 because it is the easiest. So I look, 3x has a coefficient of 3, 4y has a coefficient of 4, I'm not going to use that equation. This x has a coefficient of 2, but looking at this y, it does have a coefficient of a -1. So I'm going to solve for y. That means I want y equals something. So how am I going to do that? Well, I want the y to be positive, so I'm actually going to add the y to the other side. And I get 2x equals y plus 5. And then I'm going to subtract 5 to the other side. So I've isolated y. So I have 2x minus 5 equals y. All right, now let's just I'm going to kind of cross this out so I know that I've used this equation. So now I'm going to take this new name that I've come up with for y, this 2x minus 5. I'm going to plug it in wherever there is a y in the other equation. I'm going to be careful though, because this is an expression that I'm plugging in. I want to make sure I put it in parentheses. So my equation then would be, let me switch colors for you, 3x plus 4 times 2x minus 5 equals 2. All right, so I'm just going to give you a second to write that down, and I'm doing okay on time here. All right, so now I have an equation in one variable that I do know how to solve. So first I'm going to distribute. So 3x plus 8x minus 20 equals 2. Combine like terms, so 11x minus 20 equals 2. And 11x equals 22. So x equals 2. Now I still have to find y because I've only got that one part. So I'm going to go back to this equation and I'm going to do 2 times 2 minus 5 equals y. So 4 minus 5 gives me -1. And then I'm going to write my answer as a coordinate point. 2, -1. Okay, so I just had to take what I showed you earlier one step further by solving for one of the variables. So isolating the variable that has a coefficient of 1. All right, one more example. Oh, we did a good job. Okay, so our next example doesn't want to work for me, so let me write it on the board. X minus 2y equals 6, and 3x plus 2y equals 4. Okay, so before I start the problem, I look at it and say, okay, if I'm going to use substitution, is there a coefficient of 1 somewhere? And there is in the first equation, so I'm going to solve for x. I'm going to isolate x, so I'm going to solve for x in terms of y. That means y will be in the answer. So I'm going to add y to the other side, and I'm going to get x equals, you can either put it in the front, I tend to put it in the front, just like y equals mx plus b. So x equals 2y plus 6. Now that I have this new expression for x, I'm going to take it and I'm going to substitute it in wherever there is an x in the other equation to make it an equation in one variable. So I've got 3 times 2y plus 6 plus 2y equals 4. Now remember, be careful when you rewrite the equation because we don't want to mess up because we've rewritten the equation wrong. Okay? All right, so now it's an equation in one variable, so it should be pretty easy for me to solve. I distribute my 3 and I get 6y plus 18 plus 2y equals 4. Then I combine the like terms, 8y, I'm going to subtract 18 to the other side, and I'm going to get 8y equals negative 14. I'm going to divide by 8, and I'm going to simplify, so y equals negative 7 over 2. That point, now it's a fraction, and yes, fractions are answers, so don't be afraid if you get an answer that's a fraction, but now I still have to find x, so I'm going to plug it back in up here, and I get x equals 2 times negative 7 over 2 plus 6. Did I do all that right? Okay, good. And now I simplify, then multiply, and I get x equals negative 7 plus 6, which gives me negative 1. So my answer here would be negative 1 comma negative 7 halves. All right, hopefully I did all that right. All right, so let's just recap. Solving by substitution. You solve for the variable, or you solve for the variable in one of the equations that has a coefficient of 1. Tomorrow we'll talk about what to do if we don't have any. But for now, solve for the variable that has a coefficient of 1. Take that new expression you've created and plug it in for the variable that you solved for. Okay? Make the equation an equation in one variable and solve for the variable. Then take that variable and go back to find the missing variable. Okay? And we're going to practice this tomorrow in class. If you have any questions, definitely review and watch it again because it was a very short video, and I'll see you tomorrow. Okay, bye-bye.